In this video, we are going to learn continuous probability distribution and the properties of a normal distribution. A continuous random variable has possible values that form an interval. A continuous random variable probability distribution is specified by a curve that determines the probability that the random variables falls in any particular interval of values. Probability distribution of a continuous variable must have two properties. First, each interval has a probability between 0 and 1. This means the probability for the interval is given by the area under the curve above the interval. Second, the interval containing all possible values has probability equals to 1. It means the total area under the curve equals 1. Recall that the shape of normal distribution is symmetric and bell-shaped. It is characterized by the mean mu and its standard deviation sigma. The probability of observing values within any given number of standard deviations from the mean is the same for all normal distributions. The last property here actually implies empirical rule. This is the empirical rule we learned before exam 1. Even though the probability of observing values within any given number of standard deviations from the mean is the same for all normal distributions, the shape is affected by the difference in mean and standard deviations. If the mean is decreased, then the curve shifts to the left. If the mean is increased, then the curve shifts to the right. You can compare the red curve and the purple curve. The mean for red curve is 0. It decreased to mu equals to -2. So the curve shifts to the left. To understand second paragraph, you can compare the red curve with green curve. The population variance sigma square equals to 0.2 for the red curve. It increased to 1. So if you compare the green curve to the red curve, you can see the green curve becomes wider. So the standard deviation is increased, then the curve becomes wider. So this is what we call narrower. The green one is what we call wider. The area under a normal curve across any interval of values represents the proportion of the population with the characteristic described, and the probability that a not randomly selected individual from the population will have characteristic. We will use the area under the curve to identify what percentage of data falls within any number of standard deviations from the mean. So this is what we call area under curve. It represents the probability between mu subtract z sigma and mu plus z sigma. This is what we call within z standard deviation of mean. Z here is a number. It could be 1, 2, 3, or decimal number like 1.43.